Hey guys, welcome back. So today is day 3 for compound inequalities. So let's go ahead and write down today's objective. Today's objective is I can solve and graph compound inequalities. Now the new part is the word solve. Okay, so we're going to be having to solve the problem, solve the inequalities, and then graphing them. Okay, now I know you've seen this 3 times already, but let's just go ahead and write it down. Compound inequality consists of two inequalities connected by an and or an or. Okay, now for number 1 and 2, this is review, so I'm going to give you guys a second to do this on your own, and then we're going to go over it. So go ahead and do that on your own right now. Alright, so hopefully you got those correct. So I'm going to go ahead and read this one for you right now. It says, to participate in the teen marathon, you have to be between the ages of 13 and 19. Write and graph a compound inequality to explain who is eligible to participate. Now, if you have to be between the ages of 13 and 19, comparing 13 to x, x would have to be greater or equal to 13, okay? Comparing 19 to x, x would have to be less than or equal to 19, because those are the teenagers, okay? This is an and problem, so we are going to go ahead and put and in between them. Now, when we graph this, we're going to put 13 and we're going to put 19. All right, these are or equal to bars, so we're going to put closed circles because we are including that. Okay, now for the blue one, the 13, all right, we're going to put a number in here. Let's say 100. 100 is bigger than 13, so we're going to go up and to the right. For this one, negative 100 would work, so we're going to go up and to the, what is this, left. Okay, so now, we're always looking for and, we're always looking for overlap, okay? The overlap would be in the middle where you see green and blue. So we're gonna go ahead and do that. Now, the other place you see overlap is at 13 because there's a blue closed circle and then there's green above it. So that's gonna be included in the solution. Over here, there's a green closed circle and blue above it, so that's going to be included as well. So it's from 13 through 19 and everything in between. Now, since those are the only numbers, when it says what are some solutions, I don't mind you writing all those numbers, okay? So we got 13, anything between 13 and 19, which would be 14, 15, 16, 17, 18, and then also including 19 because 19 has a red circle over here, okay? So those are all those. Now for this one, this is the complete opposite. It says to participate in the teen marathon, you have to be between the ages of 13 and 19. That part's the same. Now the different thing is that we need to know who's not eligible, okay? And who's not eligible are kids under the age of 13 and adults over the age of 19 are not eligible, okay? Now it says kids that are under 13. Okay, we're not saying 13 and under, so that means we're not including 13. So when you're comparing x to 13, all right, someone who's under 13 would be like 12 or 5 or 6, so we'd have to put a less than symbol. All right, now we would not put an or equal to bar because it doesn't say 13 and under, it just says under 13. Same thing with the 19. For this one, we're comparing x to 19. It says adults over 19, so that would be like 20, 27, 64. So 64 would be greater than 19, okay? All right, but not equal to it because they didn't say 19 and over. All right, now the other thing here is you see the or, so we're gonna put the or problem there. All right, we're gonna go ahead and put 13, we're gonna put 19 in there, okay? This time we do not have or equal to bars, so these are gonna be open circles. All right, and now let's go ahead and not shade, but draw those arrows. Now for the green arrow, number that would work in here would be like negative 100. Negative 100 is smaller than 13, and negative 100 is this way, so I'm going to shade that way. Over here, 100 is bigger than 19, so I'm going to go up and over that way, okay? Now, or means at least one of the shading. So since I have at least one over here, I have green. So I'm going to shade over here. Over here I have at least one, which is the blue. So I'm going to shade over there as well. The middle will not get shaded because there's nothing there. Okay? And the other place that there's nothing is at these open circles because of the fact that they're open circles. So the only solutions would be on this side and on that side. So any number on this side would work. There's an infinite amount of numbers there, so just use a couple. So 3, 8. Now the highest you would go is 12. So I got 3, 8, 10, and 12. The lowest you would go in this area is 20. So 20, right, 35, 64, those are all going that way. And obviously you can go further than that, okay? So those are the solutions. Now, we're gonna get to solving, but before we get to solving, I do wanna show you something because this is going to appear and I don't want you to be surprised by it, okay? Now, and compound inequalities can be rewritten in a way where the inequalities are merged and the and part of it disappears. All right, so we're going to use the answer from number 1 to show you that. So for the answer from number 1, we had x is greater or equal to 13 and x is less than or equal to 19. Now, the way that you merge this is you bring down the two numbers in order, so the 13 would come before the 19. Okay, and then you're going to put an x in between them. Now looking over here, between x and 13, the arrow is pointing at the 13. So between x and 13, the arrow has to point at the 13. Okay, over here, between x and 19, the arrow is pointing at the x. So between x and 19, the arrow has to be pointing at the x. So now they look like two less than symbols, which is what it's supposed to look like. Now, this right here is what I mean by merging it, because over here, the blue and the green merge to look like this. This is what an and compound inequality looks like without the and in it. All right. Now you see all those solutions that we picked, or that satisfied 13, 14, 15, 16, 17, 18, 19. If I put any of those in here, it will still be true. For example, if I put 13 in here, 13 is equal to 13, and 13 is smaller than 19. Okay. If I put 14 in here, 13 is smaller than 14, and 14 is smaller than 19. Okay, it works with all these. So 15 works, 16 works, 17, 18. 18, let's see what 18 looks like. 13 is less than 18, and 18 is less than 19. Okay, now the last one was 19, and that one would still work because 13 is less than 19, and 19 is equal to 19. Any of those numbers that go in here is true. So this is the answer to, this is another way to write your answer for number 1, okay? Now for number 2, all right, now it says, now see what happens when you try it with the or. So if we were to try this with the or, again, we put the 13 before the before the 19, and we put the x in the middle. The arrow is pointing at x between these guys, so it's got to point at x. The arrow is pointing at 19, so it's got to be pointing at the 19. Now, if we pick one from the top row, like say we put 8 in there, now 13 is bigger than 8, but 8 is not bigger than 19. So this is wrong. So that doesn't even work, okay? Now, if we tried one from the other column, like 64, 13 is not bigger than 64. 64 is bigger than 19, but the fact that it's not 13 is not bigger than 64, that doesn't work either. So why am I showing you this? Because I want you to know that you can never merge them with the or problems, only the and problems, okay? All right? And when they are merged, it is easier to solve them. So let's go ahead. Actually, if you need to press pause so you can write all this down, go for it. All right, so let's take a look at number 3. For number 3, we have x is less than, 4 is less than x plus 5, which is less than or equal to 8. Now this is a merged problem. Now the fact that it's a merged problem automatically makes it an and problem. It's an and problem. Okay, so what we're going to do is we're going to solve it. Now what I need to do is I need to get x by itself. Now say that this wasn't here, this would be a regular one-step inequality. So what you do here is you would subtract 5 from both sides. But the fact that we have a merged and problem, we have 3 sides now. We have the 4, the x plus 5, and the 8. So when you add or subtract 5 to get rid of it, you got to subtract 5 in all 3 places. So over here, we have 4 minus 5. Over here, we have, these are going to cancel. Over here, we have 8 minus 5, okay? So this is going to turn into -1 is less than x, which is less than or equal to 3, okay? Now this right here, again, is an and problem, okay? So we are going to look at the overlap, all right? Now, we have -1, and we have 3. Now 3 is going to be a closed circle. Now for this one right here, all right, this is going to go, if I put a number in here for this part, this would be like maybe 100. So -1 is smaller than 100, and 100 is that way. Okay, over here, -100, so we'll be going this way. So you can kind of imagine an arrow going that way and an arrow going that way. So the overlap would be in the middle, okay? And we would also include this right here because it's a closed circle, okay? Now for number 4. Number 4 is an OR problem because there's an OR in it, okay? And you will never see an OR problem that does not have an OR in it, all right? If there's nothing in it, it's automatically AND. So we gotta make sure we understand that, okay? Now, when it's an OR problem, what you're gonna do is you're gonna solve them individually. So for this one right here, this is a one-stepper, okay? So x minus 3 is less than 2. So what we're gonna do is we're gonna add 3 to both sides. 3's cancel, and then you get x is less than 5. Over here, we're gonna have to subtract 2 from both sides. So that cancels, and then you get x is greater or equal to 7. Now we solved them each individually. Now this is not the answer because we're missing something. We're missing the word OR. You do have to put the word OR there because this whole red part is your answer, okay? Now we're gonna graph this like we used to graph them. So we're gonna put the 5 and the 7. That's open, that's closed, okay? Now for this one, this tells me the number that would work here would be like -1,000. -1,000 is that way, so I would shade that way. Over here, x is greater or equal to 7, all right? A number that would work here would be like 1,000,000. 1,000,000 is that way, so I'm gonna shade that way. And that is my OR problem, okay? All right, again, if you need to press pause, go ahead and do so right now. All right, so number 5. Number 5, I want you guys to try this on your own. We have -4 is less than or equal to x plus 10, which is less than or equal to 7. Now go ahead, if you need to look at number, I think it was 3, it's very similar to that one. Go ahead and look at it and try this one on your own. Go ahead and do that right now. All right, guys, so for this one, again, we have 3 spots right here. So what we need to do is we need to get the x by itself in the middle. So again, if that wasn't there, usually you would just look at that one step and you'd subtract 10 from both sides. But again, since this is an AND compound inequality, there's 3 spaces there. So you're going to subtract 10 from all 3 spaces. -4 and -10 are going to get you -14. These 10s cancel out, bring you just the x. Over here, 7 minus 10, that's going to get you a -3. So this right here is the answer to the AND problem. And what we need to do now is we need to graph it. So we have the -14, and we have the -3. This one's going to be a closed circle because there's an or equal to bar. This one's going to be an open circle because of the no or equal to bar. Okay? All right? This one is going to go out to the up and to the right. This one's going to up and to the left. So the overlap is going to be right in the middle. And then over here we have the closed circle, so that one's also included. Okay? Hopefully you got that one correct. Here's the next one. We have -2 is less than or equal to 3x minus 8, which is less than or equal to 10. Okay, now this right here is very similar. You're just going to see that we have a 3 out front. So this is a 2-step. So go ahead and do those 2 steps and then we'll see what we got. All right, guys, so again, hopefully you got this correct. Now what we're going to have to do is add 8 to get rid of this one. But again, we have 3 sides, so we're going to add 8 to all 3 sides. Canceling this one out, all right? And then what we're going to have here is 6. The 3x will come down, and then 10 and 8 gets you an 18. So now it looks like this. Now right now it's 3 times x, so what we have to do is divide all 3 of them by 3. Okay? When you divide all 3 of them by 3, this becomes 2. These cancel, and then this becomes 6. So this is our new problem right here. So we're going to put the 2, we're going to put the 6. Again, we have 2 or equal to bars, so they're going to be both closed circles. All right. The number that would work in here would be like, for this one would be like 100, which would be that way. For this side, it would be like negative 100, which is that way. So the overlap again is in the middle. Okay. For an and problem, like a merged and problem, it will always be in the middle. Okay. All right. If you need to press pause, go for it. Otherwise, I'm going to go to the next slide. All right, guys, so this is the last problem we're going to do, number 7. So I'm going to let you guys try this one on your own. Number 7 is negative 3x plus 1 is less than 4, or negative 2x minus 5 is greater than 7. So go ahead and do this one on your own. All right, guys, I hope you guys didn't mess up on this one, because you do have to divide by negative, and you have to remember to switch the sign. So for the first one, you subtract 1 for both sides. Negative 3x is less than 3, but then we have to divide by a negative. Remember, whenever you divide by a negative, you need to make sure that you flip the sign. So it's a less than symbol, it's not going to be greater than. Okay, so x is greater than negative 1. Now over here, you're going to have to add 5 to both sides. That's going to cancel out the 5s, and then you're going to have negative 2x is greater than 12. Divide by a negative. Again, dividing by a negative changes the sign. So that greater than symbol now is a less than symbol. Okay? Because we divided by negative 2. So x is less than negative 6. Okay? Now this is not the total answer because you're forgetting something. You do need to put an or in there. If that or is not there, you won't get the right answer. Okay? Now, we're going to put these on the number line, but you should notice that negative 6 is smaller. So negative 6 has to go first. So negative 6 and negative 1 there, and both of them we have open circles because there is no or equal to bar. All right. Finally, over here we have x is less than negative 6, so negative 100 is less than negative 6, so that would go this way. Over here we have x is greater than negative 6, so that one would go that way. Okay. All right. So hopefully that helped you out. We are going to do some practice with this tomorrow. I'll see you guys later.